For weekly math challenge 18, we have a few winners, and the very first person to answer this question was Brian123, who correctly answered the question with the answer of 2. And we have 2 more people I would like to recognize. They also got this question right. Nasos Dimitriadis was the second person to get the correct answer, and Pedro T Ferreira was the third person to get the correct answer. And I apologize, as always, if I am mispronouncing your name. And I want to make sure I recognize all of them. And huge congratulations to all of them. Anyway, now it's time to go over the question. And the question was, n is an integer greater than 1 if x is equal to n to the nth power. We wish to evaluate log base x of this crazy thing. So let's start with the summation that's inside. Mainly the summation from k equals to 0 to r of, you have 2 things that's being multiplied together. The second thing is n choose k. And for the first thing, we have n choose n minus r plus k. And remember that when you have n choose k, that's the same thing as n choose n minus k, because this thing is picking k groups, picking combination of k things out of n, and this thing is picking what you're not wanting to pick. So n minus k objects out of n. We have one-to-one correspondence between these two. So n choose k is equal to n choose n minus k. So let's apply the identity to this expression, and that gets us n choose n minus r plus k, also known as n choose r minus k. That's more simplified. So let me put that in. So inside we have this summation, and this summation, as some of you pointed out, is a special case of Vandermonde's identity. And Vandermonde's identity tells you that summation, let's go to the right just a bit. Vandermonde's identity tells you that the summation from k equals to 0 to some r of m choose k times n choose r minus k is equal to m plus n choose r. And this makes sense. And how I like to think about this Vandermonde's identity is by using committee selection model. Committee selection model. And what I like to think is that, let's say you have m plus 1 people. And let's say m are male and n are females. And we wish to pick r of them. So we are picking group of r people from m plus n people. M is males, n is females. So we can either pick 0 from m, and pick all the r from females. So m choose 0 times n choose r is one case. Or we can pick 1 from m, and then we want to multiply using the multiplication principle, and r minus 1 from n, and we can continue adding this up until we can pick all r's from m, and you're picking 0 from n. So that's exactly equal to this summation. So we have Vandermonde's identity thinking about this committee selection model. And there may be some argument you may wish to make, because our r value in this case is going from 0 to 2n. So what if our r value was 0? What if our r value was 0 in this case? Then we have n choose 0 minus k, which is n choose negative k. How do we calculate things like n choose negative something? Or what if r was 2n, the maximum possible value? What if r was 2n, you have k of 0, because k is cycling from 0 to r, then you're going to have n choose 2n. How do we calculate something like this? And one assumption that we often make, and it's more of a convention, when you have n choose k such that n is less than k, so the bottom is greater, as in this case, or you have negative values of k when k is negative, then we say n choose k is equal to 0. So whenever something crazy like this happens, when there are some exceptions that we can't really think about using committee selection model, they are just going to become 0. So the ones that are causing problems are not going to be taken into account when we make this calculation, so we do not have to worry about them. Anyway, so now let's think about what this summation is equal to. One way is to just apply van der Waals identity, or another way is to think about committee selection model once again. We have n males and you have n female. So we have total of 2n people, and you're picking r of them, and we can either pick 0 from this one and r from this one, or 1 from this one and r minus 1 from this one, and obviously we're doing summation to take all of those into account. So this entire summation, this inner summation simplifies to 2n choose r. So we have log base x of summation from r equals to 0 to 2n of n minus 1 to the r times 2n choose r, because this entire thing is 2n choose r. So what do we do now? So we somehow want to simplify the summation, and maybe you recognize this as binomial summation. You're adding, this is going to be a binomial. And why? From binomial theorem, you may recall that x plus y to some n's power is equal to summation from k equals to 0 to n of n choose k times x to the k power times y to the n minus k power. When you look at the exponents, we have k and n minus k. So overall, we have n things going on. You have k plus n minus k, or n exponents that you're splitting between x and y. And for example, if we have x squared and y cubed when n is 5, then x squared y cubed can be done several ways. It can either be xx y y y, it can be xy x y y, or y x x y y, and so on. So we want to multiply by 5 choose 2. The number of ways to place 2 x's out of 5 things. So that's why we're multiplying by n choose k, and we are doing the summation from k equals to 0 to n. So all of the terms are taken into account, from x to the 0 y to the n to x to the n's y to the 0. So we know this binomial summation and realize that this looks very much like binomial summation indeed, because it is one. So let's look at this summation. R equals to 0 from 2n, n minus 1 to the r, 2n choose r. And tricky part is to recognize that you can also multiply by 1 times 2n minus r, because 1 to the any power is going to be 1. And see how we have something choose k. We have n, instead of n choose k, we have 2n choose k. So in this case, our exponent is going to be 2n. And we have our some value x, n minus 1, raised to this power. So raised to this power. So we have n minus 1. And we have the rest of it, 2n minus r, which is raising 1 to the power of that. So we have another plus 1. So this thing simplifies to n to the 2n power. So we have log base x of n to the 2n. And what else do we know? We know, so let me write it down. So this entire thing simplifies to log base x of n to the 2n. And we know n is equal to n to the n's power. So we have log base x to the n to the n's power times 2, because this 2 can be factored out. And this entire thing, we have log base n to the n's, because x is equal to n to the n's, of n to the n's is going to be 1. But we still have to take care of this exponent, and using property of logarithms, we can just bring them out. So we have 2 times 1, which is equal to 2 at the end. Another way of thinking about it, you can think of what do we have to raise n to the n by? What do we have to raise n to the n by to get n to the 2n power? And it's pretty obvious that the answer is 2. So the final answer for this question is 2.